Good morning. Today we'll discuss cluster analysis methods. First method is partitioning methods. There are a number of methods. The first method is the partitioning methods, then hierarchical methods, density based methods, grid based methods, evaluation of clustering. So among which we'll see the first method partition methods in this presentation. Okay. First we'll define the data partitioning. Data partitioning in data mining is the division of whole data available into 2 or 3 non-overlapping sets. For example, if you have a database, there you have a number of data points. So all these data points can be divided into 2 or 3 non-overlapping sets. These can be listed like the training set, the validation set, and the test set. Why we need to go for data partitioning? The basic idea of the data partitioning is to keep a subset of available data out of analysis and to use it later for verification of the model. Once if you do partition, it will be available all the time. When it is required, it can be used for verifications. Now, exactly what we are doing in the partition methods. The given database D, which contain n objects, it can be set into a number of clusters, it's a K cluster, such that the sum of squared distance is minimized, where Ci is the centroid or middoid of the cluster Ci. This clustering method classifies the information into multiple groups. Why we need to go for clustering? When you go for clustering, the clustering method classifies the information into multiple groups based on the characteristics and similarity. So, the clustering will be done based on the characteristics or similarity of the data. The data analysis first of all need to specify how many clusters they need. So, need to specify the number of clusters K that has to be generated for the clustering methods. The given K, find partitions of K clusters that optimize the chosen partitions criterion. We have two different criterions. One is global optimal, another one is heuristic methods. The global optimal means exhaustively enumerate all partitions. Okay. In case of heuristic method, we have two things again. One is a K-means, another one is a K-middoid algorithms. In K-means, each cluster is represented by the center of the cluster. We have number of clusters. Each cluster can be represented by the center of cluster in K-means. In K-middoid, each cluster is represented by one of the objects in the cluster. We have number of clusters. Each cluster contains number of objects. One object will represent the cluster. The K-middoid will also be called as PAM, that is nothing but partition around middoids. Now, the K-means clustering method is nothing but is a partition algorithm. It can be implemented in 4 steps. The first step, partition objects. Here, the object can be partitioned into K non-empty subsets. This is the first step. And second step, compute seed points as the centroid of the clusters of the current partitioning. Okay. And the third one, assign each object to the cluster with the nearest seed point. And fourth one, go back to the step 2. Stop when the assignment does not change. Okay. These are all the 4 steps we need to remember when you go for implementation of K-means clustering algorithms. Now we will try to implement these 4 steps. First, we have a data set. This is the initial data set in which you have number of data points. Now the data analysis given K value, that means K equal to 2, means the data points must be clustered into 2 clusters. So arbitrarily partition objects into k groups. And here we identify two different groups. One is these are all one group and these are all another groups. Okay. So the two groups according to the k value, it is divided into two. So two groups were identified. Then update the cluster centroid. Now we will try to identify the centroid. Centroid is nothing but the center of the cluster. Okay. So here we identified one of the data point will act as a centroid. Okay. Here for this group we will have one centroid point will act as a centroid. Data point will act as a centroid. Now reassign objects. Okay, means with this centroid, what are the objects around available that can be moved into this group, and to this centroid, if there is any data points available around, it can be moved towards this centroid. So you will be having two clusters. This is one cluster, this is another clusters. See here, this will be moved to here and this will be moved to here. Okay, so it is moved to here and this is moved to here. So we have two clusters. Then update the cluster centroids. So where we located this centroid, that must be updated. Okay, it is updated. And again you have to do the same step. You have to repeat this step from second step. This process will be done until there is no change. So these are all the 4 steps. 1, 2, 3, 4. 4 steps. Okay. So with the help of these 4 steps, the k-means clustering algorithm will be implemented like this. Now, the strength of the k-means algorithm. Here we have 3 parameters. One is t, this is iterations, and how many iterations you are going to have no change, and k, how many clusters you want to create, and n, how many data points you have in a cluster. Okay, so based on this, the efficiency of this k-means algorithm will be defined. The weakness, it is applicable only to the k-means algorithm is applicable only to objects in a continuous n-dimensional space. That is using the k-modes methods for categorical data. In comparison, k-medoids can be applied to a wide range of data only. Okay. So these are the weaknesses. And before going to cluster, they need to specify the cluster. How many clusters you need to create? The number of clusters in advance, it must be specified. And it is very sensitive to noise data and outlier. When you find any data point outside of the cluster, then that will be called as noisy data or outlier data points. So, but with this noisy data, you may not be able to create a cluster. So it can be removed. And it is not suitable to discover cluster with non-convex shapes. The next, the variation of the k-means method. The most of the variants of the k-means which differ in selection of the initial k-means. The variants, okay, will differ in selection of the initial k-means. Okay. And second one, dissimilarity calculations. Okay. When you find this cluster, there you have to identify the dissimilarity data objects also. So there also you find some difficulties. And strategies to calculate cluster means. Okay. So these are all the most variants of the k-means differ. Handling categorical data k-modes. Here replacing means of cluster with modes. Then using new dissimilarity methods to deal with categorical objects. Using a frequency based method to update modes of clusters. and a mixture of categorical and numerical data is a K prototype methods. So what is given over here? Handling categorical data, we need to consider the more K modes and dissimilarity measurements, then frequency based methods, then mixture of categoricals. So all these things we need to consider when you go for handling categorical data in K-means algorithms. What is the problem of K-means method? A K-means algorithm is very sensitive to outliers. Since an object with an extremely large volume may substantially distort the distribution of the data. So when you have large volume of data points, there is a chance to have outlier also. The outlier, if you are unable to identify properly, then it will try to disturb the clusters. And second one, K-midpoints. Instead of taking the mean value of the object in a cluster as a reference point, midpoints can be used, which is the most centrally located object in the cluster. So a midpoint in the sense, you are going to identify the data point which will be the most centrally located object in a cluster. So now you can take this given data sets. There you have two clusters. This one cluster, this is the another group of data points. Okay. From this you can identify this midpoint. Midpoint is the data point where it is located centrally in the clusters. For this cluster, it is located in center. For this cluster, it is located in centers. With this, you can create the clusters. With this centroid, midpoint, you can identify the other data points. You can move into the to the clusters. See here, the first one is a data point. It is a given data points database. There you have number of data points. So the given k value is 2. Means what? You need to create two clusters with these data points. So we identify two clusters. This is one cluster. This is another cluster. And here we need to identify midpoints. Okay. So midpoint is almost a data point which is located center of the cluster. If you identify this is the center of the cluster, then it can be defined as a midpoint. Okay. This is another midpoint for this cluster. For this cluster is a midpoint, and this for this cluster is a midpoint. Now with this you can create the cluster. With this you can create the cluster. So cluster is created. Cluster is created. Now, if you find any other data points or near to this centroid, it can be moved to here. It can be moved to here. Okay. Okay. Then randomly select a non-midpoint object. Okay. You can, for example, you can choose this one as a midpoint, for example. Okay. And this will be moved into midpoint positions. So with this data point, you need to identify all other data point. It can be moved towards this data midpoint. Then you have to create the clusters. So compute total cost of the swapping. So if you're doing like this, you have to check the cost of the swapping. Okay. So initially this was the midpoint. Now we are going to choose this one as a midpoint. This is red color. This is a midpoint. So it is going to be swapped. So what is the cost of our swapping? So the cost will be calculated. Okay. With here, by choosing this one, the cost will be 20. Here, by choosing this one as a midpoint, the cost will be 26. So again, we are going to iterate. The iteration will be started from the second step. From this step. Okay. So again, this process will be iterated until the quality is improved. So swapping, okay, swapping. If the quality is improved, then it will be the loop will be ended. So do loop until no change. Is a find. K-midpoint clustering is a find representative objects. Midpoint is a clusters. Form we already discussed. Okay. We start from initial set of midpoint and iteratively replace one of the midpoints by one of the non-midpoints if this includes the total distance of the clustering resulting clustering. and PAM works effectively for small data set but does not scale well large data sets.